Hi, Isaac. I am just recording the video for the question that you asked on the homework here. Let me punch it up real quick here. So it says a consumer group says the mean minimum time it takes for a sedan to travel a quarter mile is greater than 14.7 seconds. A random sample of 20 sedans with an average or the mean minimum time traveled a quarter mile was 15.5 seconds and a standard deviation of 2.09 seconds. At alpha being 10% or 0.10, is there enough evidence to support the claim? And there's many parts to it here. So first things first, as you write it out, I just kind of wrote all of it out already here. I did it two ways. I did it with the, it's called the rejected region. And I also did it by the p-value because that's the way the book wanted it done. So real quick here. So you should know. So if you say greater than 14.7 seconds, this will greater than sign or less than sign or non-equal to. So the alternative hypothesis cannot have an equal to sign anywhere here. So that means if you say that the mean average time is greater than 14.7 seconds, that means that has to be the claim right there. So that means the null hypothesis would have to be the exact opposite of it. So this means the average time would be less than or equal to 14.7. So just based upon that, we have a little bit of information. We do not know the population standard deviation, and we know it's one-tailed because of these signs here. All right, let's go through it again real quick here. So we know there was a sample of 20 sedans. The average was 15.5. The sample standard deviation is 2.09. And there's the alpha level. So I just kind of did it all there. If you did it by rejection region, which the homework does not allow you to do so, but I just want to show you here, this is the way I taught it in the videos. You'd plug into this formula right here. You'd get this little t value. And then you have to look in the back of your book to the chart that's in the back of the book for t values. And you're looking for the one-tail test. And we go from there. That's their value for the one-tail test based upon the calculation here, and then based upon the value from the table, and then you compare the two. All right, so just real quick here, just so you know, you got to do this by calculator here. So I'm going to come off of that. Let me just quickly get to my calculator here on my computer. If it'll allow me to do so, let me do that. I got that, and I will show you how to do it on the calculator. So because we do not know the population standard deviation, what we've got to do is we have to go to our stat button right here. Boom. We're going to go to tests. The one that we're looking for is the t-test because we don't know the population standard deviation. You click on that little guy, and you could either bring in data, but we're not going to do that. We're going to do stats because we have all the stats in front of us already here. So the mu naught is 14.7. The average for our sample is 15.5. The standard deviation for our sample is 2.09. And there were 20 sedans that were there. And now the question, what's the relationship to mu and mu naught? So you have to kind of combine things together, but this was the relationship. It is that mu is greater than mu naught. So enter, calculate, and there you have it. And so what you're looking for the homework is a p-value. So notice this is 0.01, 0.051, or 0.052. So in that case, what you got to do is you got to put that in. So there's the end result here. If you want to take a look at it here, let me zoom in on it real quick here. So I did it right. Just want to make sure I did it right here. But here's the answers to the values here. So here's your 14.7. The claim is alternative hypothesis, the t-value calculated, and the p-value based upon that. And then we reject the null hypothesis because the p-value is not greater than alpha. All right, hopefully that helped you on the test. Or sorry, on the homework.